Hello, friends. The topic of discussion of this lecture is the use of pointers in C, which is one of very famous topic, and it has a huge application in computer science. So, how we can use a pointer variable, and it has a huge application in data structure subject of computer science as well. There's a lots of application of pointer variable use. So, let me start with a very basic description of pointer variable. So we will start with the description. What is pointer variable first that I need to describe. The pointer variable is a special type of variable. During the definition of a data type of variable, I already discussed that pointer is a special type of variable which actually store the address of another variable. So instead of storing the value directly into a variable, it will store the address of that variable. So we will check it how it will store the address of the variable and how it will access the address of the variable, and what is the advantage of using pointer variable. No, so pointer variable can be of different types. It may be integer pointer variable, character pointer variable, float pointer variable, and so on. And the size of a pointer variable depends on the architecture of a system. So system to system, architecture to architecture is varies. So generally in case of 32-bit architecture of a system, the size of a pointer variable is 2 bytes. Okay, this size is important because MCQ questions are coming to asking about the size of a pointer variable. Now, how we can define a pointer variable? The very basic definition to define a pointer variable, we use this special sign. It is not a multiplication sign here. It is a special sign which is called asterisk sign, or in technical term, it is also called indirection operator, which represents a variable which is a pointer type. Right. So difference between a non-pointer variable is can be defined in this way, and a pointer variable can be defined in this way. Is it clear to you? Now, according to definition of the pointer variable, it will actually store the address of a variable. Now, to store the address of a variable, we have to use a special type of operator which is called address of operator. I think all of you are already familiar with this operator ampersand, because in scanf function we have frequently used this ampersand operator, and inherently a scanf function is working like a pointer, because the CPU will point to a particular memory location in a stack where you are going to store the value whichever you are enter through your keyboard at runtime. So that is the scanf function ampersand operations, okay, or address of operations. The same operation here, the pointer variable p is working. Here the normal variable n store a value 10, which is an integer type. Obviously, this p store the address of the variable n. Obviously it should be an integer type. If it is not an integer type, then there should be a type mismatch, because whatever variable address it has been stored, the type should be matched. Okay, so in this way pointer variable can be defined, and pointer variable can store the address of another variable. This is a simple declaration and definition of a pointer variable. So it's an indirection operator, I have already told, and asterisk sign. Now there are various types of pointers. So this is the pictorial representation of a pointer variable. If p here is a pointer variable and n is a number variable which has stored the value 50, and p point to the address, p actually stored the address of this n variable. So that is fff4. So this fff4 has been stored by the pointer variable p. So if we are not using a pointer concept here, if you are using p equal to n, and suppose p and n both are normal variable, then instead of assigning to the address of that variable, it will directly assign the variable. That means the value of the variable directly assigned to the p. So there is a difference between pointer variable and normal variable. Now I am going to show you how a pointer variable and how we can access the address of that corresponding variable. So this is a very small code snippet I have given to you. Int star a comma b. Here star represents the asterisk sign or pointer sign in pointer a and b. Obviously from here we can understand this is a pointer variable a, and this is a normal variable b which store the value 10. Now a equal to ampersand b. Very simple, I have already discussed. So a is a pointer variable which stores the address of another variable b, which is a normal variable. Now, how to print the address? If I want to check the address of a variable or b variable, we have to use this special type of access specifier, which is %p. It is very new to you. %d, %f, we have already used %lf. Several access specifier you have used for different purposes, but this access specifier used to represent the address of that variable. So if I want to fetch the address of the variable a, that will be represented by %p. And now if I want to fetch the value which has been stored into a, that can be done by %d. Obviously value is an integer type, so represented by %d, and it can be represented by star a. Sometimes that's why it is called dereferencing. Dereferencing means a equal to ampersand b is called referencing, and when we are going to do star a, that means we are fetching the value at that address. That means a represents only the address of the variable b, and star a represents the value of that address of variable b. So what is the value of that address? Value which has been stored by the address of b. The address of b store which value? 10. So star A represents what? 10. So here star A and B both are similar values. Okay. So B will, if we print B, it will give 10. If we print star A, it will also give 10. So please remember, star, a pointer, star sign in front of a pointer variable always represent the value at address. Okay. And the normal variable without star, a pointer variable always represent the address of another variable. Here it will represent the address of B that I have already showed in this picture representation, the address of B, right? So just for sake of simplicity, we will run this code. So you can check the value, the address of A has been given in this hexadecimal address form. It has been represented, and this is the value at address A is 10. Clear? So this address is actually defining or allocating by the CPU itself. So it is not fixed always. It may fix it may repeat the same address for the next run, or it may repeat it may given a defined address for the next run. We will check it. It may give the same, or it may give the defined address. So it totally depends upon the CPU. So we should not control it. It actually given, I think it is given the same address. So it totally choice of the CPU how it will deal with addresses, right? So this is all about the pointer variable, right? The very simple definition of a pointer variable. Now, in case of pointer to an array, how we can represent the pointer and how a pointer variable is accessing the array. Now, before I'm going to going to deeper into the pointer and its different operations, I want to say that why we're using pointer variable. The pointer variable has the advantage of faster applications, faster accessing of the values, right? Compared to normal variable, pointers operation are much faster. Okay, it may be addition operation, subtraction operation, or any sort of operations we can perform. It pointer using array, pointer using functions are always faster than normal variable operation. This is one of the advantage of pointer operation, because it accessing the addresses directly instead of values. Okay, because to access the values, the variable first has to search the address and then access the values. Are here directly accessing the addresses instead of values. Okay, so that's why it's faster. Now, some basic operation that I need to discuss regarding pointer variable. There is one more concept of pointer variable that is called null pointer. There is always a good practice to assign a null value to a pointer variable in case you do not have an exact address to be assigned. Suppose we don't have an address to be assigned, so automatically it will not consider it as a null. We have to explicitly assign that pointer variable as a null variable. So you may check this code snippet in start ptr. Suppose I don't know the address of this pointer variable which has to be assigned, which has to be pointed by this variable. So that's why I have replaced it by a null. Okay, null represents actually 0. So the value at this address. Okay, if I want to find the address of this ptr, %x is sometimes also used for the address print. %p you can use, or you can also use %x to print the address. So it is the address of the value is actually 0 because it is a null, right? Sometimes it is a use of null pointers. Okay, now there is a concept of pointer arithmetic, right? What is the concept of pointer arithmetic? Pointer arithmetic. Before we are going to moving into pointer arithmetic, I want to show you pointer to a pointer concept. It means chain of pointers, pointer to pointer or chain of pointers. Sometimes the question will come, what is chain of pointers? Very simple. When multiple pointers or multiple indirection operations are working together, and then it is called chain of pointers. A pointer to a pointer is form of multiple indirection or chain of pointers. Normally, a pointer contains the address of a variable. When we define a pointer to a pointer, the first pointer contains the address of a second pointer, which points to a location that contains the actual value. Very simple. Don't make it confused. So what is pointer of a pointer? This is a normal pointer variable which stored the address of a variable value, which I have given the example for our case. This is the pointer variable A which stored the address of B, right? So here, if this is a pointer variable A, then it will store the address of B. Now, what is this pointer chain of pointers and a pointer variable? Which will store, instead of directly the variable address, it will store another pointer address of another pointer variable. Okay, so how it will represent it? It will represent by two star, two asterisk or two indirection operator simultaneously, and it can be do a chain of pointers. You can go an infinite number of pointers here. So the 3 star will represent another pointer which will store the address of this pointer. So in this way, the chain of pointers can be moved. So in several applications, we are using the concept of chain of pointers. So let's try to apply a chain of pointer concept here. So A is a pointer variable. So there is another variable, suppose uh, suppose var, which will actually contain the address of the pointer variable A, right? So here um, we will print two addresses. Let's check. So A gives the address of B and where gives the address of A. Clear? A gives the address of B and the where gives the address of A. And here we will make star where. It is actually value at address of pointer to pointer variable, right? So it will look like this. So I think this star A will print the value of B that is equal to 10, and what will be the print value of star where? Let it check it. So you can find it. This is the address of A. This is the address of where. Okay, not address of where. Actually, this A actually stored the address of B. This is actually address of B because A stored the address of B by the help of ampersand operator, and where is actually stored the address of A. A is another pointer variable. So it successfully executes. Now the value. Both are actually giving the value 10. It will be very natural that star where is also giving the value of 10, which is a value pointed by a pointer A. So A points the value at address B, okay, and where pointer the value which has been A pointed by. So both are 10. Clear? So this is a chain of pointers. So I think you should go through the chain of pointers in details because questions are coming from chain of pointers. Now, next discussion about the pointer arithmetic. Okay, passing pointer to a function. Before that, we will going to discuss about pointer arithmetic. Pointer arithmetic. One second. Now, what is pointer arithmetic? There are several concepts of pointer arithmetic. How we can increment a pointer variable. The pointer variable can be incremented in this way. We can increment the address of a pointer variable. We cannot increment the value of a pointer variable. Please remember, we cannot write the code like star ptr plus plus. Star ptr plus plus is invalid code because the address, the value of a pointer variable cannot be incremented because pointer variable is nothing but is pointing to an address of a variable. So address can be implemented, and which if ptr is a pointer variable, then what is the address, what is the address which it will store actually the address of another variable, and it will store in this, the address will store in this format ptr. If we will put star in front of this, then it is not store address, it is stored a value at address. So that plus plus operation, minus minus operation, or any sort of increment decrement operations cannot be performed on this star form, okay, on this value at address form. It is always performed on the ptr form that stored the address directly. Clear? So ptr will point to the location 1004 because each time ptr is incremented, it will point to the next integer location, which is 4 bytes. So it will actually, if the ptr value, initial value is 1004, the next value of the ptr after ptr plus plus will be 1008. So 4 bytes extra location. Now this 1008, the value which has been stored within that location of 1008, that will be fetched by the help of start ptr after incrementing the value. So incrementing a pointer, this is a pointer increment operation. I hope you must practice this code. Okay, just look at this code and you can practice at home. So in this case, variable is an array. So how to access the array of a pointer? Very simple. Here I have given you the idea of accessing the array of one. If integer array of 10, integer star p of 10 equal to ampersand add. This pointer is actually stored the address, the first value of the array here. Okay. In my next lectures, in future lectures, I will also discuss in more detail about the accessing of a pointer. Okay, how to do the operation, the how to do pointer comparison operation, how to two pointer can compare with each other. Please check all these operations which are important. Okay, so I'm just skip this down because I think these operations are very easy to for you to understand. Okay, now let me show you how to access an array through a pointer. Suppose this is an array where, so this is a general program without pointers, an array where, and we are trying to run a for loop for I equal to 0 to maximum. The maximum value I have given here 3, initialized as 3, and I comma where of I, that means for each and every iteration it will print the corresponding variable, the variable array value. Okay, so all the 10, 100, 200 will be printed one by one. Now there may be a situation when we want to maintain an array which can store pointers to an int or char or any other array type. These are integer pointers, okay, which actually has a value of max, which is 3. So int star ptr max means int star ptr 3. So this is a pointer array. This is a pointer array which has stored maximum 3 values. So how we are going to access this pointer array? Assign the address of the integer. So instead of we are accessing through the value, we have to access through the address. Please remember, pointer variable is always accessed by the help of its address, not the value. Okay. So ampersand verify the address of the variable of the ith position. That means if it is in starting it is 0, then the address of the variable of the 10th position. That means it is address, corresponding address, not this 10. Corresponding address will be stored into a pointer variable of the same position 0. So ptr0 store the address, contains the address of variable 0. Okay, that means a 10 position address. Okay, now if we print start ptr of I here, then it will return, it will not return the address, it will return a value at address. That means it will return all the 10 to 100 200. Same lines of code can be executed by using pointer in this way. Okay, so we will check the other cases, as well. So let's do some code in compiler. um, Here I have doing some code. So this is one of the code where I am performing an arithmetic addition, the sum of two numbers. How we can perform a sum of two numbers using pointers? So sum of two numbers we can perform using pointers in this way. So these are int main functions. Here two pointer variable I have defined, star ptr and star qtr. Okay, two values, two variable, general variable I have defined, fno and sno, first number and second number, which are two integer type. Our objective is to find the sum of these two variables. So first we have to store the address of fno variable into star ptr and address of sno variable into star qtr respectively, and then we will perform the addition of the numbers. We are not performing the, if you are doing ptr plus qtr instead of star, then it will add the addresses, not the values. Please remember, whenever we're performing addition, we actually are performing the addition of the values at address. Okay, so we can do start ptr plus start qtr. Start represents the value at address of the ptr, which is nothing but a value of fno, and start qtr is also represent the value at address at sno. So it will actually um, sum up these two values and give the answers. Check it out. First, let me give you the value of first number 8, second number 6. This is the output 14. Okay, so successfully done. So this is the one of the example of how to do arithmetic addition through a pointer variable. Please remember all these examples. Okay, these are very important. Now write a program to see add numbers using call by reference. The same thing, the addition of two numbers using call by reference. But before that, I want to show you uh, how to this is one of the very interesting concept, and how to pass a pointer variable through a function. That is very important. So one question is very frequently come: write a C program to do operation which will show a call by reference applications or call by address applications. So till now, whatever passing value through a function we have done, the programs for passing value through a function all are called by values. Okay, only we are passing values. Okay, if you remember any function, factorial function, if you remember the factorial function, we are passing only one value, int n, for which we are calculating the factorial. So we are directly passing the value of the variable n, right? We're passing the variable in terms of value. So here we are not passing the values, here we are passing address of the value. That means instead of n, we are passing ampersand n. Ampersand means the address of the value. Let's check it out. This is the one of the example of how to do uh, passing an array, passing a pointer through a function. Okay, so find fact is a factorial function. So here num1 is a number for which I am going to calculate the factorial. So that has been taken through a runtime input, and find fact is a function call here. Num1 called ampersand fact. So you can understand this ampersand fact is actually the address of the fact variable. What is the fact variable? Where is actually this value has been stored, right? So here we can do that ampersand num1 and fact ampersand fact1. So num1 we are passing, which will be passed in terms of n, right? So star f equal to 1, So for I equal to 1 to n I plus plus star f equal to star f into I. Okay, star f equal to star f into I. So this is actually into sign, and this is a star sign. Star means the pointer sign, and this is actually into sign. There is difference between two signs. Okay, this is individual operator and this is a multiplication operator, right? So it will actually multiply it, and it will return it will print the value or return the value that will be printed here, right? So let's check one more example, one more easy example to understand. This is one of the very famous example that I used to show you. I want to show you uh, how to do swapping of two numbers that we have already done in our normal cases. Okay, now first I want to show you how to do swapping using call by value. Call by value means in normal cases using functions, how to do swapping without using pointer. Okay, let me show you first. So in this case we'll activate these statements. So two numbers I have taken as an input for which we are going to swap. So before swapping, we will print those two numbers. Now swap function has been called and two numbers has been passing A and B, for which we are applying swap. Now void swap function we are calling by taking these two numbers. Now one temporary variable, the third variable swapping using third variable temporary variable I have taken and do the swapping operation, which I have already explained multiple times. And after swapping, we will print the value of AB. So run this code. Sorry, let me change this thing because we are not using pointer here. So the first value is 8 and suppose the second value is 6. So before swapping it will be 8 and 6, and after swapping it will be 6 and 8. So swapping has been done successfully. Okay, now we will do the similar operations with using pointer variable. And what I said, the similar operation can be done by using pointer variable in much faster way compared to this normal operation. This entire operation is called call by value if you are not using any pointer variable, or if you are not passing any address. Instead of passing, we are directly passing the values or variable names. So here we deactivate these lines and activate these lines. So if you check it out, what we have changed here, we have called the functions. Instead of we are directly passing the variable a and b to the function, which is called call by value. Here we are actually doing call by reference. Call by reference. This is called call by reference or call by address. Okay, this term is very frequently come into the exam. Call by address means we actually passing the address of a variable. Okay, which is not a direct variable value. We are passing, instead of value we are passing the address, some address in the form of hexadecimal numbers. Now there should be something into a swap function which has the ability to store the address. So which variable has the ability to store an address of another variable? Obviously there is a pointer variable. So that's why we have used two pointer variables, star a and star b. We may use the same name, you may use the different name, no issue. The same operation will be happening. Instead of star a star b, if you use f and x, it will do the same operations for you, same job for you. So ampersand a is address passing through the star a is a pointer variable, accepting by star is a pointer variable, and ampersand b accepting by star b is another pointer variable. Now we are going to just do the swapping operation using this star pointer variable. Obviously we are doing the swapping on the values, not the addresses, so that's why we are using star here. Okay, instead of ampersand here. Please clear the concept of when we are using ampersand and when we are using star. When we are dealing with the values, operation with the values, summation of two values, multiplication of two values, subtraction of always we are using star. But whenever we are incrementing the operations, incrementing means we are incrementing the address to the pointer. So multiple, so if an integer, then it will be incremented by 4 bytes. If it's a float, it will be incremented by 4 bytes. If it's long, it will be incremented by 8 bytes, and so on. So after swapping, it will be printed with star a and star b. According to this, we have declared the prototype of these functions, and just run this code again, whether it will successfully run or not. Let me check it. The first number value is 9 and second number value is suppose 12. So before swapping, it will be 9 and 12, and after swapping, the value will be just interchange. Okay, so our program is successfully run. So this code is very important. Okay, please remember this code because frequently a question has come: what is the difference between call by value and call by reference? Show with one example. Okay, so call by reference and call by value. When this call means you have to show by using function. Otherwise, this call terms cannot be used. Okay. So that is the call by value and call by reference using swap functions. Very interesting and very important program as well. So just we will stop the discussion of the basic of the pointers. So let it digest first by you. Read the materials which have been provided in the Google Classroom and start the basic concept of pointers. And in my next classes, I will do the discussion. I will continue the discussion with some more facts of pointers and its corresponding operations. Okay. So thank you for watching it, and please prepare it according to according to your conceptions. And if you have any sort of queries, please ask in a Google Docs, Google Classroom comments. And thank you for watching.